Hello students, Lesson 7 takes us back to a discussion of Earth's history. With Lesson 6, we wound up with a discussion of a timeline for the entire universe, and we're going to narrow down that timeline now looking at planet Earth. So this will be a big picture for Earth's history. It's definitely been long, lots of natural catastrophes. We had that density stratification of Earth's interior, very important. Movement of the continents, opening and closing of ocean basins, that's related to plate tectonics, one of our future topics, and also the evolution and extinction of life have occurred during Earth's long history. So here's that timeline of Earth's history we started perusing in Lesson 6. I believe we looked at the left-hand column showing the big picture, the Big Bang, which occurred about 13 billion years ago, galaxies forming, solar nebula 5.5 billion years ago, Earth formed 4.6 billion years ago, and then right down to the present. So we've covered that. What we want to focus in on is the next column. So column number 2. We'll focus in on it because it's the most relevant to our origins discussion. So again, take a look. 4.6 billion years ago, Earth formed. Ocean formed by 4.2 billion years ago after some 400 million years of rainfall as water condensed from that toxic volcanic atmosphere. Oldest rocks dated at about 3.8 billion years ago. Well, note, we have recently discovered older rocks found in Greenland. So that actually pushes that number 3.8 back to 4.0 billion years. And this is good. This just points out the fact that science constantly learning and changing through time, and that's okay. The oxygen revolution at 2 billion years ago, very critical for you to have a grasp of. So from 3.6 to 2 billion years ago, we had oxygen being released by bacteria and primitive plants, but it was largely bound into iron-rich minerals at Earth's surface. We call that process oxidation. By 2 billion years ago, those minerals at the surface had taken in all the oxygen they could, and that means that oxygen that was still being released by primitive plants and bacteria could then start building up within the atmosphere. This is important, folks. This increase in free oxygen enabled more complex organisms to evolve on Earth. And a special note to us, you would not be taking this online course if not for the oxygen revolution. So definitely, it's a critical event in Earth's history for the biosphere, but also for other aspects of planet Earth. So there's our timeline. We can see some of the other aspects. If you look at column 3, animals arose some 800 million years ago. According to the fossil record, fish appeared 510 million years ago. Breakup of Pangaea just over 200 million years ago. That's that supercontinent where all the continents were together as one. We'll talk about that again when we get into our discussion of plate tectonics in the near future. And then column 4, look at that, humans appear about 3 million years ago. These are not humans that would be your neighbors. These were primitive hominids that have evolved and changed over a period of 3 million years, giving rise to Homo sapiens, that'd be us, some 500,000 years ago. So we are truly new organisms on this planet. Column 5 is different. It projects into the future from today and looking ahead 3.5 billion years. Yeah, the sun's output will be too low to keep the ocean in the liquid state. It's going to start to freeze up. Then some 5 billion years into the future, the sun will swell into that red giant phase we discussed previously, and that will vaporize the ocean and eventually the planet as well. So this is a timeline of Earth's history. Gives you that big picture overview of how things have changed in the universe and especially on Earth and how things might play out into the future.